All right, today's lesson is 2.6 day 1. By the end of today's lesson, you should be able to find the domain of rational functions, find the horizontal and vertical asymptotes, and then analyze and sketch graphs of rational functions. So if you look at overall what a rational function is, you could rewrite it as f of x equals n of x divided by d of x. N of x and d of x are both going to be polynomials. And d of x is not going to be 0 because you can't divide by 0. So the domain restrictions occur when the x values cause the denominator to be 0. So if I look at these three pictures of rational functions, in the first one, I have a vertical asymptote at x equals -1 and a horizontal asymptote of y equals 2. The second picture has a horizontal asymptote at y equals 0. And then the third picture here has a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 0. So these are overall pictures of what a rational function will look like. So if you look at the asymptotes of a rational function, so for step 1, the graph of f has a vertical asymptote at the zeros of d of x. So you find the vertical asymptotes by calculating the zeros of the denominator. This is only after you've canceled out any common factors. Step 2, we're going to be looking at the horizontal asymptote. The way you determine the horizontal asymptote is by comparing the degrees of n of x and d of x. So if you look up top here, n of x has a degree of n, and d of x in this general function has a degree of m. So if you compare those degrees, if the degree of the numerator, n, is less than the degree of the denominator, m, that means that it has y equals 0 as a horizontal asymptote. If n equals m, so if the degree of the numerator equals the degree of the denominator, then it has a horizontal asymptote at the line y equals, and what this means is the ratio of the leading coefficients as a horizontal asymptote. And then the last case is if the degree of the numerator is greater than the degree of the denominator, that means it has no horizontal asymptote. So that's how we would calculate horizontal and vertical asymptotes. But notice this starred statement below. It says the zeros that are the common factors of the numerator and the denominator, those create holes on the graph. So it's possible to have asymptotes and holes. So if I look at the guidelines for analyzing graphs of rational functions, the first thing we're going to do is simplify. The common factors will be the holes. Step 2 says we're going to find and plot the y-intercept by plugging in 0 for x. Step 3, find the zeros of the numerator. Essentially, that would give you your x-intercepts. Step 4, find the zeros of the denominator. That would give you the vertical asymptotes. Step 5, we're going to sketch the horizontal asymptotes by using those 3 rules that we just talked about. Step 6, we're going to plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. And step 7, we're going to use smooth curves to complete the graphs between and beyond the vertical asymptotes. So if you look at this first example, it breaks it down into A through E steps here. So if I start with A, it says find the domain of the function. So on this one, the domain would be all real numbers except for what would make the denominator 0. So in this case, except for x equals 3. For B, there was no common factors that were canceled out, so there's no holes, so that means this is continuous. Part C says identify all intercepts. So if I plug in 0 for x and solve, I would get 1 over 0 minus 3. So that would give us negative 1/3. So that means there's a y-intercept at 0, negative 1/3. If I plugged in 0 for f of x and solved, if you notice, if I multiplied both sides by x minus 3, I would be left with something such as 0 equals 1, and that's not possible, so there is no x-intercept. Part D says identify any horizontal and vertical asymptotes. So I'm going to start actually with the vertical asymptotes. So the vertical asymptotes are those values that don't work in the denominator. So in this case, it would be x equals 3. Notice the domain and the vertical asymptotes go hand in hand. For the horizontal, we have to compare the degree of the numerator and the degree of the denominator. So if I looked at the degree of the numerator here, n would equal 0. The degree of the denominator, you would get 1. So 0 is less than 1, which indicates that it will have a horizontal asymptote at y equals 0. So let's start plotting these asymptotes so we can kind of see what's happening on the graph. So at x equals 3, we have a vertical asymptote. At y equals 0, we have a horizontal asymptote. It looks like at 0, negative 1/3 is our y-intercept. So that would just be a little bit below that x-axis there. And so part E says plot additional solution points as needed to sketch the graph. So that means we're just going to pick some points that are to the left and to the right of the asymptote to give us a good picture of the graph here. So if I looked at some values for x, so the asymptote's at 3. So let's pick some points to the left of 3, so like 1 and 2, and to the right of 3, so 4 and 5. So we're just going to plug these values in for x and solve. So if you plug in 1, 1 divided by 1 minus 3 would be negative 1/2. If you plug in 2, 1 divided by 2 minus 3, that would be negative 1. If you plug in 4, you would get 1 divided by 4 minus 3, so that's 1. And if you plug in 5, 1 minus 5 minus 3 would be 1/2. So these give us a couple extra points to see the overall shape of the graph. All right, so I'm going to plot these. So 1, negative 1/2. So to the right 1 and down 1/2. And then 2 is to negative 1. 4, 1. So we would go to the right 4, up 1. And 5 is at 1/2. So we have to figure out how to sketch these points. So if I look from the y-intercept, I know that it's going to approach that horizontal asymptote, but it won't cross it. I can connect these points, and I know it's going to hug the vertical asymptote, but not cross it. To the right, we know the same thing. It's going to approach that asymptote and that asymptote. So you know that this is just a sketch, but that is the overall shape of the graph for f of x equals 1 divided by x minus 3. So if I look at the next example, if I'm looking at the domain here, part A says find the domain of the function. So my domain is all real numbers except for what would make the denominator 0. So except x equals 1. There are no common factors here, so I can say this is continuous. For part C, I can plug in 0 for x to get the y-intercept. So 1 minus 3 times 0 over 1 minus 0. Well, that's just going to equal 1. So I have a y-intercept at 0, 1. For my x-intercept, I can essentially just set the numerator equal to 0. So I could say 0 equals 1 minus 3x. So if I solve here, I would get negative 1 equals negative 3x. So I know that my x-intercept would be at positive 1/3. So that's the ordered pair 1/3, comma 0. All right, for part D, it says to find any horizontal or vertical asymptotes. For D, we have a vertical asymptote where the denominator equals 0, so that's x equals 1. The horizontal asymptote, we have to compare the degree of the numerator and the degree of the denominator. So if I look here, x is to the first power, so this has a degree of 1. In the denominator, x has an exponent of 1, so that has a degree of 1. So it looks like the degrees are equal, so it's going to be the ratio of the leading coefficients. Be careful on this one. The leading coefficients, this function can be written as negative 3x plus 1 over negative x plus 1. So the leading coefficients is actually going to be negative 3 over negative 1, which we would, of course, simplify to get y equals 3. So let's start plotting the vertical asymptote. So it was at x equals 1. And then y equals 3. All right, so now we have to kind of plot some points to the left and to the right of the vertical asymptote. So if I make a table for part E here, for x and for y, or f of x, I want a couple values to the left and to the right. So I'm going to pick at least one point here. So I'm going to plug in negative 1 and 3. So I want you to do that math. 1 minus 3 times negative 1 divided by 1 minus negative 1. That would give us an output of 2. And then if you plug in 3, so 1 minus 3 times 3 over 1 minus 3, that would give us an output of 4. If you need to pause and do that math by hand at this point, that is fine. So if I am graphing, we are going to not only use these points, but our intercepts to help us graph. So 0 is at 1. The x-intercept was negative 1/3, positive 1/3, comma 0. So that would be somewhere within there. So then negative 1 reaches up to 2. And then 3 was 4. So to the right 3, up 4. So you know it's going to essentially hug these asymptotes. And this would be the overall shape of my graph. Okay. All right, now let's actually look at one that needs to be simplified a little bit. So it says, example 3, we want to do all of those steps with f of x equals x squared minus 2x minus 8 over x squared minus 9. So the first thing we're looking for is holes and to see if anything will cancel. Well, if you factor x squared minus 2x minus 8, that's going to be x minus 4, x plus 2. And then x squared minus 9 is x plus 3, x minus 3. There are no common factors, so I know there's no holes here. So if I look at part A, the domain. So my domain would be all real numbers except for what makes the denominator 0. So in this case, it would be except x equals plus or minus 3. There was no wholes or factors canceled, so that means this is continuous. Part C says figure out where the y and x intercepts are. So if I plug in 0 for x, I get 0 squared minus 2 times 0 minus 8 over 0 squared minus 9. So that's going to just be positive 8/9. So my y-intercept is at 0, 8/9. My x-intercept, if I set the numerator equal to 0, so we can say this is x minus 4 times x plus 2 equals 0. So I know that I have two x-intercepts. One is at 4 and the other is at negative 2. So my x-intercepts are at 4, 0 and negative 2, 0. And then part D, we want to figure out the vertical asymptote and the horizontal asymptote. So if you look at the vertical asymptote, remember you could kind of steal this from the domain. X equals 3 and x equals negative 3. So I will have two vertical asymptotes. And then the horizontal asymptote, in this case, the degree, again, of the leading coefficients is 2 and 2, so that's equal. So we would take the ratio of the leading coefficients. So in this case, it would just be y equals 1 divided by 1 would be 1. So at this point, I would start plotting what we have. So it looks like we have a horizontal asymptote at y equals 1. And a vertical asymptote at 3, x equals 3, and x equals negative 3. And then let's plot our x-intercepts as well. So my x-intercepts are at 4, 0, and at negative 2, 0. So we now have to kind of make our table and plug in these values. So I want a couple to the left and to the right of the vertical asymptote. So if I make my table here, so if I say for part E, x and f of x. So we want a couple values to the left of negative 3. So I would just plug in negative 4 and negative 5. And then we want some values that are in between negative 3 and 3. Well, I already have 1 point, so I probably would just need one more to get the shape of the graph. So in between negative 3 and negative 3 and positive 3, I would graph 2. And then we can also plot something to the right of 3. So I already have that x-intercept to the right of positive 3, x equals positive 3, so I'm going to just pick something to the right like 5. All right, so in the interest of time, I did the math previously for this, so if you plug in negative 4, you can always pause the video and do this by hand yourself. You would get 16/7. If you plug in negative 5, you would get 27/16. If you plug in 2, you would get 8/5. and 5 would be 7/16. So remember, 16/7 is the same as 2 and 2/16 for graphing purposes. You know that 16/27 is 1 and 9/16. And 8/5 you know is the same as 1 and 3/5. Okay. So before we graph these ordered pairs, let's also put the y-intercept on our graph here. So 0, 8/9 would be a little bit above the x-axis there. Okay, so let's plot -4 and then 2 and some change. So to the left 4, down 2 and a bit. -5 is 1 and 9/16. So down. Excuse me, so -4 was positive. 2 and 2/16. And then -5 was 1 and 9/16. So if I look at the far end here, I know the graph is going to hug those asymptotes and look something like this. In between -3 and 3, we had picked 2. So 2 was 1 and 3/5. So I hope you're asking yourself, if I connect these dots, I would start from that y-intercept and go up and hug that vertical asymptote. And then I would do the same. I would start at this y-intercept and then hug that vertical asymptote. Do you notice how it crosses the horizontal asymptote? That's possible. Horizontal asymptotes just help with the extreme ends of the graph. So extreme to the left and extreme to the right. So in the middle of the graph, like we have here, sometimes you will see it cross that horizontal asymptote. And then the last thing we have to graph is 5 and then 7/16. So to the right 5. 7/16 would be somewhere up in here. So you can then connect those points hugging the asymptotes. So that is our final answer for that graph. All right, if